This is the first video where we're looking at solutions for the handout using the lens equations worksheet 1. Let me read question 1 to you. An object is placed 32 centimeters from a converging or convex lens that has a focal length of 8 centimeters. Determine the image location. If the object is 3 centimeters high, how high is the image? If the image is the image real or virtual? Is the image inverted or upright? Well, we have a converging lens, so when we have that, then the focal point is given a positive value. We're also told that the distance of the object is 32 centimeters, and we need to find di. So we have our lens equation here: 1 over f equals 1 over di plus 1 over do. So we need to rearrange this to isolate di. So let's subtract 1 over do from both sides. Okay, and when we rearrange this thing, what we're going to get is 1 over f, 1 over f, subtract 1 over do equals 1 over di. We can just flip it, of course, to make it easier to write from right to left, or left to right, I should say. So 1 over di equals 1 over f, subtract 1 over do. Now all we have to do is just substitute our values here. So 1 over di will equal 1 over 8, subtract 1 over 32. And when we plug those values into our calculator, 1 over di will equal 0.125, subtract 0.03125, and 1 over di will then equal, if we subtract this from this, we're going to get 0.09375. To find di, all we have to do is find the inverse of this, so di equals 1 over 0.09375, and then di will equal 1 divided by that. Plug that into your calculator, and you're going to get an answer of 10.67 centimeters.